I can give you the world's most boring demo if you want, because our product is an API. I'm guessing no one actually wants that. So I'll actually walk you through some slides and just humor me for 2 minutes. I'm going to give you a little bit about the industry background I'm in and why global payroll is such a problem. And I realize some of you might be kind of far removed from the entire problem. So this is me and my co-founder in our younger days, obviously. So the CTO at a company called Velocity Global, EOR provider like Deal and Rippling and so on. And one of the problems we saw there was related to HR operations. So if you can think about companies like Deal or Rippling or Remote, essentially as outsourced HR. You tell them to do the hiring, run the payroll, give them benefits, and so on. And a company like Velocity Global, now it's been renamed Pebble actually, a company like Pebble will actually run payroll for 80 to 100 countries every month. And so the difficulty with payroll, of course, you can understand every country and often geographies within the countries have actually their own way of dealing with compliance. They've got their own rules, how you take a gross salary and convert it to a net salary, how frequently you need to do tax filings, what laws are being changed all the time. Every country has got its own thing. And the result of that is essentially that, you have to run payroll like this. Every single step of the way, you've got manual steps in payroll. And it doesn't matter what country you're in. Almost without fail, every country has got these kinds of manual processes. And for a company like Velocity Global or Pebble, to run 80 to 100 payroll every month meant you've got contracts with 80 to 100 companies within those geographies in which you're running payroll. Those folks are going to run payroll for you, and they're going to present results to you, and you need to put that back into your system so that you can present it back to your client. And the reality is that most of the companies that you contract with, so you've got a company in India who's doing Indian payroll for you, someone in Germany who's doing German payroll for you, these typically tend to be smaller houses which are using spreadsheets typically to run the calculations, and they send data back to you over email. And so most of these HCM companies or these global EOR companies have large operations team which take care of these things. At Velocity Global, there were close to 150 people who would run payroll every month. And it would typically take about 3 weeks between the time in which a customer provided their inputs. Here's the salary I want to pay. There are 3 weeks of delay before the paycheck can actually be handed over to an employee, because this is the time you go back and forth and do all the calculations and exchange spreadsheets and find inaccuracies and fix it. Inaccuracy, timeliness are endemic in the system. And some of you might not realize, because most of our white collar workers don't think so much about it. There are added complexities when you live paycheck to paycheck, or you've got you're an hourly employee and calculations need to be done, or you're working overtime, you have this kind of a job, and therefore these are the calculations because you live in this geography. There are incredible number of complications. So I will skip over this thing. The bottom line is payroll is hyper local. Geographies, each geography, each country has their own favorites, payroll provider. Who's, if you look at Germany, for example, SAP is the big player there. In the US, of course, there's ADP. There are a couple of other players also. In India, there are companies like Darwinbox now. So every geo has got primary players. And in fact, the little known secret is even the biggest payroll and HCM companies in the world use their competitors in order to run payroll in the geographies in which they're actually strong, right? There is no global payroll platform, and that's the very small goal that we have set out to tackle. We want to build a global payroll platform. And so let me jump in and tell you a little bit about how AI actually fits into our landscape. So if you look at the US, for example, the IRS has something called Publication 15. If you have ever had the pleasure of going through Publication 15, it's about 150 pages of dense PDF. It says, if you have 2 children and if your salary is more than this much, then this is the deduction that you need to have. And oh, by the way, you're a business and you're making more than $10 million, then you need to pay your taxes every other day instead of every week. It's complicated, and it's all meant for human consumption. So what we have built is what we fondly call our LLM sandwich. And one of the things that we kind of decry is the fact that AI has become equated with LLMs. It's not the same thing. There are traditional machine learning techniques which are really important, and TurboTax, which I had the privilege of working on when I was at Intuit, actually uses computational graphs. And we think computational graphs are incredibly powerful, underrated technologies for the right kind of problems. So our LLM sandwich kind of looks like this. The bottom layer is the knowledge capture, where you've got raw material like publication 15 coming in, and it comes in and hands it over to this knowledge extraction LLM. And the knowledge extraction LLM's job is to take this document and actually convert it into the computational graph in the middle, each which has got multiple nodes. It's got hundreds of nodes actually, or thousands of nodes. And each node makes one kind of decision, right? So imagine, I'll just talk about the middle layer for a second. Imagine that you're married, you have 2 children, you live in California, and you make $100,000 a year. All those will be inputs into the middle layer, and you will visit different nodes depending on what your inputs are, and the nodes will do different calculations for you. That's what we want to do. That's the heart of the system. In order to get there, the bottom layer takes this raw material, which is this schedule 15 kind of thing. It extracts these rules and hands it over to these critics on the right-hand side. And the job of the critics is to criticize what has been produced. So it looks at the output and says, no, I'm scoring you a 4 out of 10 because you haven't taken this condition into account and you haven't done this. So different critics with different specialities, and they know about very specific parts of the law. And it's their job to judge whether the output that has been produced is acceptable or not. And critics have different forms. Some of them are AIs. Some of them, we've got a human in the loop system also, is being orchestrated by a popular package called LangGraph. And in addition, we also have some mathematical models to validate whether all this is hanging together and makes sense or not. So it's kind of fascinating when you watch the bottom layer. These guys are arguing back and forth and disagreeing with each other. And at the end, either a valid graph gets produced, or there is a disagreement. They just throw up their hands and say, sorry, I just don't like you. I don't agree with what you're saying. I give up. In which case, a human expert comes in and actually reviews and makes a decision about what needs to be done. So we still have human in the loop. I actually think that's important. In our opinion, this is an 80% system, and there's also always going to be 10 to 20% human judgment going to be involved, at least in the current state of affairs with the state of technology here. Once this work is done, it goes to the middle layer. I've kind of described it. That's the computational graph. This is really the heart of the system. This is the meat in the system, so to say, between the two layers of bread on the either side. Input comes in, with information about salary and family circumstances, whatever else. There are hundreds of different variables that can come in. It goes through this computational graph. It goes through a verification algorithm. Computational graph basically produces a set of output. Each one of these nodes produces a certain output. And that output gets captured in an audit log, which is super important. And I'll explain that to you in a second. It goes through the entire node, and out comes an execution log with the results. And the execution log is super important to us because what happens is it actually feeds our customer support use cases. That is, if a customer comes in and says, hey, what the heck, you've deducted $25 more in FICA from me. Why have you done that? What we do is take the entire audit log for that particular run, for that particular consumer, and feed it into an LLM and say, here's what happened. Here's every node that has been visited. Here's the decision that has been made. Convert it into an intelligent response for the user. So you get a hyper-personalized response. And this is actually a game changer for us, because if you think about it, when I described companies, payroll companies who are trying to do global payroll, and you have got a company in India actually doing the back office payroll calculations for them. If a consumer comes in and says, why have you done this calculation? The payroll provider has no idea, because they've got to turn around and give it back to the Indian operations and say, can you figure out what's going on? And 2 weeks later, you have an answer. And by that time, your customer is all pissed off anyway. We actually do the answers pretty much instantaneously, with a pretty high degree of confidence in the answer that has been produced. And there are a few things in here which we think are unique and interesting. The bottom layer, we have spent a lot of time fine-tuning that. We use a mixture of agents. That is, we are completely agnostic to which LLM should be used for any given circumstance. It's a configuration parameter for us. And we actually use a mixture of agents. The knowledge extraction LLM, our current favorite is actually Gemini right now, but we can throw it out and replace it with the flip of a switch, mostly because the context window is really large and we really like that. It does a good job with that. Whereas some of the critics, we have found that Claude Sonnet actually does a really nice job. So we are actually using that. So the entire process, the bottom layer is completely configurable. If tomorrow, someone else comes up with the next brilliant, maybe NanoNets fits in over here, we just plug it in. It's a pure configuration change for us. So that's how AI fits into our system. And we are really like the fact that I think it was Jayanti was talking about deterministic versus probabilistic systems. Payroll is a deterministic process. We actually don't want LLMs in the process because you ask the question 100 times, you want to give you the same answer every single time. And of course, with a probabilistic machine, that's not going to happen. We use the probabilistic machine at what it's really, really good at for extracting the knowledge and getting to a good point, and then we feed it into a computational graph for actually doing the calculations. So that's us. We are an early stage company, just got seed funding. We are tackling one of the hardest countries in the world first, which is Germany. Call us foolish, but we are thinking that if we can solve Germany, other countries will be easy for us. So that's us. Thank you very much.